Hey everybody, this is Alex Merced, and you're listening to an episode of Data Nation. And what I want to talk about today is table formats and how table formats relate to different languages and engines and their implementations. Oftentimes, I think there's a lot of misunderstanding of how this works. So let's just kind of walk through the process. So basically, again, a table format, if you're not familiar with these, are things like Apache Iceberg, Delta Lake, Apache Hoodie. What these do is that they create a standard way of writing metadata that allows tools to understand that, hey, these 1,000 Parquet files are not just 1,000 Parquet files, but they are a unified data set, tracks metadata around that unified data set so that we can more intelligently scan that data set, allow for asset transactions, do time travel, lots of really cool things that normally you would associate a database or data warehouse system with. But how does it do that? Okay, so there's different levels that this is done. Okay, and some of these formats are much clearer about these layers than others when you read their documentation, but essentially there's the standard, that's the metadata format. And that's not a script, that's not code that you run, it's a standard of how you write certain JSON, Parquet, Avro files that store the information about the dataset. Okay, so for example, in Iceberg, it's a mix of sort of Avro and JSON files. Basically, you generally have one JSON file that is the metadata file that kind of tracks all the table level sort of definitional items. And then you have two Avro files that track, well, two types of Avro files. One that tracks the groups of files that are part of a particular snapshot, and then Avro files that capture the different files that are part of each group. Okay? And then that's essentially how it's structured. Okay, and again, why Avro? Because generally you're looking at rows of different files, and you're going to want to sometimes transactionally pick up different files and understand different files. So row makes sense. While in the case of the JSON file, you're looking at a variety of different metadata that's not necessarily structured as a bunch of sequential rows, so JSON makes more sense. Now, when it comes to Delta Lake, that standard is set up as a series of JSON files that represent different commits or different delta logs. So every time you make a change to the table, you create a JSON file that catalogs that change, and then you have these Parquet files that represent a group of changes, aka a checkpoint file. Okay, and then Hoodie gets a bit more complicated. Basically, you have a metadata table. And I think some of these are stored in custom formats. I think some of them are stored in H file. But basically, you have separate files that contain a metadata table that contains sort of just general table statistics. You have different indexes, which are stored in separate files. And then the changes to every individual file are actually done as file slices. So essentially, you have the original file and then these other files that are log files that track changes to the data in those particular files. So everything's kind of broken up a lot of files, and again, part of it is because it's trying to really handle very, very real-time streaming. That's what Hoodie was built for. So it's splitting up a lot of this among a lot of files, so that way, if you're writing little bits to different files, you could potentially just update those writes quicker for that real-time consistency, and also less likely that you're going to have multiple writes sort of collide with each other. But it is I find it a little bit more difficult to sort of wrap my head around. Okay, so but that's the standard. So again, that's not the actual code that actually creates these files. It's just a standard for, hey, what are the files that do the thing? So then what happens is these projects, what they do is they generally write libraries. Usually the first library is in Java, because most data tools are typically and traditionally in Java. So you write these Java libraries that basically have all the different classes and methods that basically take in the information needed to write this metadata and then return the information an engine would want when they read this metadata. This way that any tool that wants to adopt these formats, they don't have to rewrite the wheel. Okay, as far as reading the metadata and writing the metadata, there is a library that just kind of does that. So they just have to worry about collecting the information to pass these methods and handling the information that these methods return. Okay, so if I'm a tool in Java, again, in this case, let's say Spark, Dremio, Trino, okay, any of these tools written in Java, then basically I would then grab the jars from these particular libraries, and that's going to give me the read and write functionality. Okay, but then again, they're just going to pass the end result back and forth. So then, sort of implementing more some of the advanced features or taking advantage of some of the more advanced indexes built into these formats is on the engine to take advantage of them. Okay, and to enable them. Cool. Okay, but again, those Java libraries are going to only really benefit tools that are written in Java or have bindings to other languages, but the functionality is written in Java. Okay, so this is why typically a lot of these projects, they have sort of mirror repos. Okay, so like in Delta, you have a Rust repo. I think now Python, and then of course there's like Python version of Delta, which I think is still part of the main repo. I don't think that's a separate repo. I'm not 100% sure on that one. In Iceberg, you actually have a separate repo now for Python. It's been separated out. And then there is a separate repo for Go and Rust, and probably in the future other languages. So why are they doing that? Well, there's tools written in other languages. Okay, so just because you have a standard doesn't mean people want to rewrite all that logic. And again, if the idea is if you want people to embrace open standards, you have to kind of give them the tools to kind of make it easier to embrace those open standards. Okay, so in that case, there's like, these other language libraries, but they're not necessarily at feature parity. They don't necessarily have all the functionality of the Java, because again, all that functionality didn't get written into the Java library overnight, and the way some of these other languages function are slightly different. So some aspects of it sometimes have to be rethought or approached from a different way. But a lot of that functionality then gets re-implemented into these other languages. So that way, hey, if I'm creating a library that's built in Python that wants to handle, so that way I can just natively in Python handle reading and writing Iceberg metadata, I can do so. And that's going to allow, tools like Polars and Pandas and DuckDB to be able to add Iceberg read-write functionality into those libraries. Same thing for like libraries in Rust and in Go, etc. So that's the reason why there's these other languages, libraries, or repos, but usually their goal is to just sort of replicate what the main repo does. And again, this is just about reading and writing the metadata. So query performance goes beyond that, because once you read the metadata, so for example, if I use the Iceberg metadata readers, it'll do the query plan for me in a sense of creating a list of files I need to scan, but how fast those files get scanned and the resulting query gets handled is still going to be in large part due to the engine that you use. Okay, so if you're using something like Dremio that's going to use Apache Arrow, so it can read those Parquet files really quick into memory and process them really fast, you're going to get pretty good performance. Okay, if you're using an engine that doesn't use Arrow, they might use other abstractions to kind of get performance, but it might be different. But that's on the read side. On the write side, then it's the opposite. It's up to the engine to write the Parquet files. So in this case, generally the way it works is that, so in that case, if I were implementing write for Apache Iceberg, the tool itself writes the Parquet files and determines how to write the Parquet files, and then it's going to pass off the list of Parquet files to the metadata writers for Iceberg to handle the writing of the metadata and committing to the catalog for the table. Okay, and again, it's the same logic whether we're talking about Delta or Apache Hudi. So oftentimes, again, there's the part that the engine has to implement, which is generally working with the actual data files. So in this case, reading the data files and writing the data files. That is separate from the realm of the core data format. Okay, because the data format is just how the standard is just how the metadata is written. Now, again, some of these libraries may come with their own Parquet readers and writers that handle that writing and reading of Parquet data, but doesn't necessarily mean every engine uses those. Because again, think of something like Dremio that uses Apache Arrow. It's going to want to use its custom reader writers to get those performance benefits. Okay, from working strictly with Arrow. So that's where you're going to get sort of differences, and which is why it's important to like not when people say something like, "Hey, performance of this is why," it's like that's more of a reflection of the engine, along with the specific libraries for that format in the engine than the format itself. Okay, because again, the format is really just providing you the metadata to figure out, hey, which files you need to scan. How fast you write or read those files is really going to be more on how the engine handles that workload at that point. Okay, again, bloated metadata, which could happen because you poorly structure your tables. Generally, in all of these formats, you can, have tables that have bloated metadata, which can affect query performance. But that's, again, not a fault of the format in itself, more than, hey, you weren't sorting your data well, you weren't partitioning your data well. So you have these really large, misorganized Parquet files that don't provide very helpful metadata. So basically, the Iceberg metadata can't really provide much insight to prune these files, and then the engine has to scan through a lot more records because these files just have a lot more unsorted, unpartitioned data. Okay, so hopefully that helps think through how these table formats sort of work. Again, so they're standard, and then on top of that standard, there's libraries, and those libraries then are used to implement functionality. Now, again, each of them are different. Like, again, Apache Iceberg is pretty sort of clean about this, where essentially you have metadata readers and writers, and the engine takes it from there. In Hoodie, it gets a little funky because it's not just, the engine doesn't just handle it. There's also this ongoing table service. Okay, that's really optimized for the format. So the idea is that you run this table service. So you run this service that's going to continuously sort of optimize your tables. And it's sort of very part of how the format works and how you get the benefit from the format. So it's not just saying, hey, I have an engine that allows me to read and write Hoodie tables. Because oftentimes you're adopting Hoodie for the streaming capabilities. So it's oftentimes really using that Delta Streamer tool to kind of do those ongoing optimizations. And then with Delta, there's a lot of obfuscation of where the features exist. Because again, when people say table format features, like for example, like there's a feature in Delta Lake called generated columns. Like that's not something that's necessarily standard in the metadata. Okay, it just means like, hey, like theoretically you could put it in the metadata. Essentially, the idea is you're capturing the relationship of one column to another, so that way when you update that one column, it automatically generates the data for the other column. But the engine has to like know how to implement that and whatnot. Okay, there's compute that makes that feature a reality. It's not just a standard of how you write stuff to metadata. Okay, so what happens is that oftentimes the implementation of those features start out as sort of only available in the Databricks version. So you're like, oh, cool, Delta has this feature I can use now, but you can only use it in Databricks. So that means it's not really a feature of the format. It's a feature of Databricks when using the format. And sometimes the Databricks documentation and Delta Lake documentation can be very unclear about this. It's oftentimes one of the biggest knocks on the format. It's not clear, like, hey, what is a feature of the format? Meaning, if I use this format, regardless of where I use it, what can I do in general? Versus features of Databricks that enhance using Delta Lake on Databricks. Again, nothing wrong with that. Okay, I mean, any of these formats, you're going to use platforms that add functionality to using them, but that line can oftentimes be a little unclear at times with Databricks. I think they're trying to get better at it. At least they've said they're trying to get better about it. But it's something that oftentimes comes up with features like that, with like Unity catalog, things that often, like when they say uniformat, usually uniformat for the most part works with Unity catalog only. Like I think you can do it with like a Hadoop catalog, but like the form factor is not something that anyone would use. So really it's a feature that you would only benefit from if you're using Unity catalog and Databricks, kind of things like that. So oftentimes, like, this is just this line between what's the format versus features of the platform when using the format. So, for example, like Dremio doesn't claim that copy into, which is a function that you can use on the Dremio platform, is a feature of Iceberg. The claim is copy into is a feature of Dremio that works with Iceberg tables. It's very clear that it's not part of the Iceberg spec. It's not something built into Iceberg. It's a feature of Dremio, and when you use Dremio with Iceberg, you get that cool command that you can use. Okay, and there's other features that Dremio has that are Dremio features specifically as applied to Iceberg tables, but they are not touted as Iceberg features. So there's a clarity, there's that sort of distinction between what one tool does versus another tool does. If you're trying to understand sort of the nature of the criticism. So with that, my name is Alex Merced. Hopefully you guys enjoyed this episode of Data Nation. I'll see you all later. Have a great day and enjoy.